Hello everyone, and welcome to the lists lecture. So in this lecture we'll be learning about the list data structure in Python. And we discussed earlier that strings are a type of sequence in Python. And we're going to learn now that lists can be thought as probably one of the most general versions of sequences in Python. So let's go ahead and get started. Here I have opened the Jupyter Notebook. And we're going to learn about creating lists, indexing and slicing lists, some basic list methods, and then nesting lists, and we'll get a quick introduction to list comprehensions. So this is a quick overview of everything in this Jupyter Notebook. You can go ahead and check it out. But let's go ahead and dive into the live code. All right, here we go. So now we're in the live code. Let's go ahead and assign a list to a variable. So I'm going to create a variable name called my_list, and I'm going to create a list. So lists are constructed with square brackets, and then they have commas separating every element in the list. So for instance, if I wanted to make a list of the numbers 1, 2, 3, so right now in this format, my list is everything in between these two brackets, and it allows me to keep track of this sequence of elements 1, 2, and 3, and they're all separated by commas. Shift enter to run that cell. So we just created a list of integers. So if I say my_list, and I can remember to do tab to autocomplete, there I have my list output. So as I mentioned, this is a list of integers, but what's nice about Python is lists can actually hold different object types. So for instance, I can create my list and I'll set it equal to a new list. And this list is going to contain a string, an integer, 23, and even like a floating point number, so 1.2, and let's put another string in there for good measure. There we go. And now if I call my list again, you can see the list is holding different object types. So it's holding a string, it's holding integers, floating points. So lists can hold different object types. You can go ahead and mix and match them within the list. So just like strings, there's a length function, and the len function also works for lists. So I can say len of my list, remember tab autocomplete, and there I get the list's length is 4, and that's because there's 4 elements. There's the string, 23, 1.2, and that O string. Okay. So let's go ahead and jump into indexing and slicing. So indexing and slicing is going to work just like we explored indexing and slicing in strings. So let's go ahead and make a new list, or just reassign that list label. So I'm going to make a list of 1, that's string 1, 2, let's say 3, and then let's go ahead and put in some integers to mix it up. So 1, 2, 3 in strings, and then 4, 5. Remember, each of the elements is separated by a comma. So since this is a sequence, I can index and grab stuff in that sequence. So if I say my list, that variable name, with brackets and then 0, that's going to grab the element at index 0. And in this case, it's just that first one is that 1. So just like in strings, the notation is the same. So whoops. Let's say I want to say my list, and let's say I wanted to grab index 1 and everything past it. I can use that same colon notation, so my list, grab everything at element 1 and then everything past it. So that's 2, 3, 4, 5, because remember at index 0, that's the 1 string. So let's say I wanted to grab everything up to index 3. I can say my list, and I'll say everything up to element 3, so colon 3. And that returns 1, 2, 3. Great. So we can also use the plus symbol to concatenate lists, just like we did for strings. So if you remember from the string lecture, I could say hello plus space, let's say world, and that would concatenate it into a single string hello world. So I can actually do the same with lists. So I can say my list, and that's just the 1, 2, 3, 4, 5 there, and I can concatenate it with another list. So I'll create a new list and concatenate it. So what I have here right now is this variable, my list, my underscore list, representing my list, and I'm going to add or concatenate this list consisting of a single item, which is just a string here, and that's denoted by those square brackets. There we go. And if you notice, when you concatenate it, it basically kind of just appended it to the last item on that list. Now again, it's important to note, since we're not reassigning anything here, if I just copy and paste my list here, that list hasn't been changed because I'm not reassigning it. Okay, so if I wanted to make the change permanent, I would have to reassign it. So I'd have to say my list is equal to my underscore list plus, let's say, permanent add. And now if I check what my list is, here I've added it permanently because I've reassigned it using that equal sign. All right. So we can also use the multiplication or the asterisk symbol for duplication, just like we did in strings. So I can say my list multiplied by 2, and that's basically going to just double my list. So 1, 2, 3, 4, 5, permanent add, and then again 1, 2, 3, 4, 5, permanent add. And you'll notice the output is just a singular list of the elements twice over. So again, that's not permanent since I'm not reassigning anything. If I just call my list again, I get that original list. Okay, so if you're familiar with another programming language, you might start to draw parallels between arrays in another language and lists in Python. But lists in Python tend to be more flexible than arrays in other languages, and there's usually two good reasons for that. They have no fixed size constraint, so for instance, this list, it can be as big as we want and we can keep adding to it. So I don't have to set any restrictions beforehand. I don't have to say, hey, this list is going to be 5 elements long in the sequence. Python allows us to just keep adding and growing to that list. And like we saw, what's nice about lists in Python is that they have no type constraint. So you saw earlier I was mixing strings and integers and floating points and different object types into that list. So let's go ahead and explore methods for lists. So I'm going to say L is equal to the list, square brackets, 1, 2, 3. So here I have my list, L, equal to 3 elements, 1, 2, and 3, in that sequence. So one method we can use is the append method. It's going to be one of the most common methods you use on a list. So again, the way methods work is you take that variable or label name, put a dot, and then type in the method you use. So in this case, the method I'm going to use is called append. And then append looks like this, has closed parentheses, and the argument you pass into it is the item you want to add to the end of the list. So for instance, I want to add a string called append me. And if I look at the list now, L, you'll notice I've appended to the end of that list that append me string. So just to reiterate again, since we're using the Jupyter Notebook and it's such a great tool for learning, if I say L dot and then click on tab, it'll give me a list of all the available methods. Go ahead and check out the advanced list lectures for a breakdown of a lot of these methods, but we're going to go over a few of them in this lecture as well. And again, I can say L.append, and since we're using the Jupyter Notebooks, I can say Shift Tab, and it will give you the docstring and some additional information. So it'll tell us L.append, you put in the object, and you can append object to the end. Great. So right now we have L is equal to 1, 2, 3 append me. Another method that's commonly used in lists is the pop method. So you can use pop to basically quote unquote pop off an item from that list. So by default, pop takes off the last index, but you can also specify which index to pop off. So what I'm going to show you is just a quick example. So I can say L.pop, and that basically returns that last element in your list, and it also permanently affects your list. So it just says, okay, I'm going to grab off that last item, pop it off, and then return it back. So let's go ahead and say I'm going to say x is equal to L.pop, and I can also specify which index. So by default, the index is -1, which would be your last element in that list, but I can pop off whatever index I want by passing it through. So let's say I wanted to pop off the 0 index item, which in this case would be 1, that very first item. So here what I'm doing is I'm saying L is my list, call the pop method on it, that .pop, and then I'm passing the index I want to pop off, which would be 0, which corresponds to that one element. And I'm using the equal sign to set that equal to a variable here. Great. So if I check out what x equals now, x is equal to 1. And if I check out my original list, L, I notice now it just consists of 2 and 3. Okay, great. So it should be noted that lists indexing will return an error if there's no element at that index. So for instance, right now my list consists of the elements 2 and 3. So let's say I call index at 1, that should return 3. Remember, indexing starts at 0, so 0, 1. But let's say I said index of 99. So that's going to return an error, and if we read the error right here, it's an index error, and that's because the list index is out of range. So that makes sense. We can't index something that's out of range in that list. Okay, so let's go ahead and make a new list to explore 2 more methods, sort and reverse. So I'm going to say new underscore list is equal to, and in this case I'm going to use strings, just letters. So I'm going to say A, E, let's say X, B, and C. And the reason I'm not just doing the straight alphabet is because I'm going to show you how to sort and reverse some of this. So go ahead and make a new list that looks like that. Let's go ahead and make sure everything worked. Okay, so here's my new list. Remember, we're just using square brackets. The elements are separated by commas. So what can I do as sort and reverse methods? So if I check out new list dot and tab because I'm in Jupyter Notebook, I can see that there's a reverse method here. So let's go ahead and click enter and see what happens. As you might suspect, it reverses the order, and it's a permanent change to the list. So now it's reversed the order of that list. And what if we wanted to sort that order? Then I can say tab, let's go down to sort. And now if we check out that list, it's been sorted into alphabetical order, A, B, C, E, X. Great. So in the case of numbers, if that list was full of numbers, it would sort them in ascending order. All right. So another great feature of this data structure in Python that is the list is that they support nesting. And you'll notice a lot of data structures in Python support nesting. So that means you can have data structures within data structures. So for this example, we're going to do a list inside of a list. So let's get a quick look at how this works. I'm going to make 3 lists. I'm writing right now, well, let's say L underscore 1 is equal to 1, 2, 3. I'm going to say L underscore 2 is equal to 4, 5, 6. I'm going to say L underscore 3 is equal to 7, 8, 9. Okay, so I've created 3 lists, and I can actually make a list of lists. So I'm going to make another object called matrix, and I'm going to set it equal to a list of lists. So I'm going to say this matrix is a list itself, but I'm going to put in the elements as lists. So I'm going to say L underscore 1, L underscore 2, comma, L underscore 3. So now I can treat this as a matrix, because if you notice here, I have my list, which is the matrix, and the elements inside of it are actually lists as well. And this is what we mean by nesting data structures. So I have a list inside of a list, and this can keep going deeper and deeper. So you can have a list inside of a list, which is inside of another list. So We can again use index to grab elements, but now there's going to be two levels to that index. So the items in the matrix objects and then the items inside of that list. So I'll show you what I mean by that. So let's say I have my matrix object, which is just that list of lists, and I say index 0. So what's that going to return? That's going to return the first element in that matrix object, which will be 1, 2, 3. All right. So now that I have this first item in the list, I can actually index it again because it is a list. So I can say grab the first item in that matrix object and then grab the first item or element in that list itself by putting another pair of brackets there. So you can see that I have multiple levels to this indexing, and I'm just kind of exploring them there. So I encourage you to kind of play around, see how I can get this number 5. How would I do that? So in matrix, that's the second list or element, so I'd have to say 0, 1. And then within that one, that list, it's 0, 1 again. So that should return 5 there. And for another quick example, let's say I wanted to get 7. How would I get that? Well, we note that it's the item at the second index, right? 0, 1, 2. So it's that third item at index 2. And then 7, it's the first one, so that's at index 0. And if we get that, there we have the 7. Excellent. So I'm going to give you one last topic in this lecture, and that's going to be list comprehensions. So Python has a pretty advanced feature called list comprehensions, and it allows for quick construction of these lists. So I'm just going to give you kind of a quick sneak peek at what this looks like, but don't worry if you don't understand it because we have a whole entire lecture devoted to list comprehensions. But in case you're familiar with another language or you've kind of gone through a tutorial of Python before, I'll show you how we can build a list comprehension by basically deconstructing a for loop within brackets. Now I know we haven't gone over loops or anything, so if this doesn't make sense to you, don't worry about it at all. We're going to go over loops, statements, list comprehensions in much more detail in the future. But just for a cool sneak peek, let's say I wanted to create that first column of that matrix. I could say first underscore call as my object name and set it equal to row for row in matrix. Now I know if you haven't seen any for loops or any statements, this doesn't make too much sense, but don't worry about it. What this is basically breaking it down is I can create a list by kind of writing a flat for loop within the brackets. So we'll have lectures devoted to this in further detail, but just to give you kind of a sneak peek at what this is doing, I just created an object that consists of the first column of that matrix, that 1, that 4, and that 7. Okay, so what that basically did is just said, hey, for every element or row in that matrix, grab the 0 index of that row. And then using this list comprehension, I can actually make a list out of it. Okay, so that's a little sneak peek. We'll hit that in much further detail in the future. But just a quick overview of what we've done. I'm going to hop over back to the Jupyter Notebook. We've understood how to create a list using brackets and separating the elements by commas. We understand that a list can hold different object types, such as integers and strings all mixed together. We can use the len function to check the length of a list. We can use indexing and slicing just like we did for strings because it's a sequence. So we can use those square brackets on that list variable to go ahead and grab things from that list. We can concatenate lists using the plus sign. We can use the multiplication or the asterisk sign to multiply or duplicate lists. And then we went over some basic list methods, the append method, the pop method, sort and reverse. And then we saw a quick introduction to nesting lists. Okay, so that's it. You can go ahead and check out the advanced list section later on in this course to go over some more details of those methods. But that's about it for lists for right now. All right, thanks guys.
Yeah.
Hello everyone and welcome to the coding lecture for Dictionaries. So With strings and lists, we've been learning about sequences in Python, but now we're going to switch gears and learn about mappings in Python. So if you're familiar with other languages, you can sort of think of dictionaries in Python as a hash table. So right now I have opened the Jupyter Notebook, and we're going to be going over how to construct a dictionary, various ways to access objects from a dictionary, learn about nesting of dictionaries, just like we learned about nesting of lists, and then we'll learn about a few of the basic dictionary methods. Okay, so let's go ahead and get started with the code. So, like I mentioned earlier, dictionaries in Python are mappings, and what mappings basically are is just a collection of objects that are sorted by a key. So unlike a sequence that stores objects by their relative position, so if you remember in a list, for example, I can make a list L, 1, 2, 3. So remember, I could access things from that list by indexing. So that's how a sequence works. What a mapping is going to do is it's going to store objects with a key. So it's an important distinction since mappings aren't going to retain order like lists and strings did. So let's go ahead and see how we can construct a dictionary. So in Python, a dictionary consists of a key and then an associated value. And the value can be pretty much any Python object. So I'll make my first example dictionary by saying my_dict as the variable name. And we make dictionaries in Python with curly brackets. So if you just put shift above your square brackets, you should get these curly brackets on your keyboard. And then the way we can construct the dictionary is, the most basic example is you put in a key name, usually a string, pretty much always a string, and then what the value you want. So in this case, I'm going to put in values, and there's a colon separating the key and the value. And then we have commas separating the various key and value combos in our dictionary. So then I'm going to put colon and put in value 2. So this is probably the most basic version of a dictionary you can have in Python. So if you notice, the way we construct it is I have these curly brackets, and then I have a key, colon, and the value that's associated with that key. And then comma for every key value combo throughout that dictionary. So if you remember, we could use square brackets to access index elements in lists and strings. In this case, we're going to use the keys for a dictionary with the same bracket notation. So I have this bracket notation, but if you notice, if I put 0, it's not going to work. It's going to say key error. And that's because it's not a sequence, it's a mapping. So what I end up putting is the key instead. So if I put in key 1, it outputs the value that's associated with that key. So another important note is that dictionaries, just like lists, are super flexible in the type of data types they can hold. So for example, I can get my_dict, and I'm going to create a new dictionary now. I'll put k1 for key 1, and I can put a number such as like an integer. I can also mix data types, so I can say key 2 colon, put in a floating point number there, and let's say k3, I can set that equal to a string. Close off with another curly brackets. And so now I can say my_dict, and I can call any one of those keys, and it will return the value associated with that key. So let's try calling another item. Let's try getting that third key out there, which is string. Cool. So what's really interesting now is, based on the value that gets outputted from that key, I can then call different methods on that value. So right now, if you notice, my_dict with the k3 key is this string, which is also labeled string there. So I can actually perform different things that I'd be able to do on a string, such as index, which would output s there. Or maybe I could reverse it like we did for strings, which is colon colon -1. And then I can even call different methods. So I can say maybe like upper method, if you remember, uppercase. So what this is basically doing is it's returning that string, and I can do anything I want with that object that I'd be able to normally do with a string. Great. So we can also affect the values of a key as well. So for instance, right now, if you notice, my_dict k1, remember that square brackets, that k1 key is equal to 1, 2, 3. So if I say K1, let's say 123 minus, let's say 120, that's going to be equal to 3. So that makes sense. Right now I'm just calling that number and subtracting 120 from it. But if I, let's say, copy and paste this, you'll notice it doesn't actually affect that value permanently. But what I can do to affect that value permanently is use an equal sign. So I can say my underscore dict of K1 is equal to my underscore dict K1 minus 120. And now what that's done is it's actually changed the value that's associated with that key. And so now it equals 3 permanently. So now if I print out my dictionary just by calling it, you'll notice that I've permanently affected the value associated with that K1, that first key. Cool. All right, so now what I want to mention is that you'll notice while you're doing your various coding exercises throughout the course, you may be trying to do this type of operation a lot. This take a value, set it equal to either addition or subtraction from the value itself. So some sort of self-subtraction or self-addition, or even like a multiplication or division. So what's really nice about Python is it actually has a quick syntax for you to do self-subtraction or self-addition or multiplication and division. And what that looks like is you basically put the operation before the equal sign. And I'll show you a quick example of what I mean. So remember, right now we have my dict, the K1 key is equal to 3. So if I say my dict K1, K1 plus 100, now it's going to be equal to 103. So I can use a quick syntax to do this, to basically fast forward through this notation. And the way that works is I end up taking this plus sign here, putting it behind the equal sign, and then get rid of this notation there that's self-referencing it. So this is the exact same thing that plus minus performs the exact operation that we just did before. And you'll notice as I ran both these cells, now it's at 203. So you can go ahead and check out the Jupyter Notebook for some other examples. So for instance, if I wanted to do a self-subtraction, I just do minus equals and then the number I want to subtract itself from. You can also do multiplication equals and then division equals as well. Great. So that's just a nice syntax so you don't waste a lot of time rewriting the same object over and over again. So I can just say minus equal and then 120 here in this case. All right, so moving along, we can also create keys by assignment. So for instance, if we started off with an empty dictionary, we could continually add to it. So I'll show you what I mean by that. I'm going to make a label or a variable called D, and I'm going to create an empty dictionary. And I can create an empty dictionary just by putting curly brackets with nothing inside them. So D is now just an empty dictionary. So the way I can create a new key is through assignment. And the way I do that is I can say D, and we'll have the key be called animal in this case. And I'll set it equal to a value. In this case, I'll have it be equal to dog. And we can do this for any type of object. So I could say again, let's say D answer for a key, and I can set this equal to 42, for instance. And now if I check out what my dictionary looks like, I've actually added in those keys and the values associated with them. So this is how you can add new keys and new values to your dictionary through this sort of assignment. Okay, so now we'll look into nesting with dictionaries. So hopefully you've seen right now that Python is super flexible with nesting objects and calling methods on them. So now we're going to look at a quick example of a dictionary nested inside a dictionary. So remember we were able to nest lists, so we can actually do the same thing with dictionaries. So I can say D is equal to, and we'll make, let's say, K1 be one of the keys, colon, and in this case, that K1 key is going to refer to another dictionary. So let me close off that first dictionary, And now I'm going to have another dictionary. I'm going to call this key nest key. And to show you how deep we could go, we could even create another dictionary inside that one, and then say like subnest key colon, and then let's just put a string in called value there. And you notice this is almost like quite an inception of dictionaries. So how can we grab that value, this string right here? How do we go about doing that? So first off, I have my dictionary, and my dictionary actually only consists of one key, K1, this most outer dictionary. And the rest of it is just dictionaries nested inside. So if I say dk1, what does that return? That returns those two nested dictionaries. So I can go again and say nest key off of that return dictionary, and now I have that subnest key in that value. And then one more time, I can say subnest key, and finally I get out that value. And then again, I can call different methods on it. So I could say upper, and then it returns a capitalized version of that value. So hopefully you can see just how powerful nesting with dictionaries could be within your code. So you're probably never going to go this deep for basic codes, but it is really useful to go at least one nest deep as you get better at programming. Okay, so what we're going to do now is go over a few of the dictionary methods that are built in. So let's go ahead and create a new dictionary. I'm going to say, I'm actually just going to call an empty dictionary to go over how we can construct it again. So I'll say K1 is equal to 1. I'll say D of key 2, so K2 is equal to 2. And then I'll make one more key, and I'll have its associated value be 3. And now if I check out what my D, that dictionary, is equal to, it's equal to K1 of 1, K2 2, K3 3. Great. So now I have my full mapping, where I have 3 keys, K1, K2, K3, and then 3 values associated with each of those keys, 1, 2, and 3, respectively. Okay, so there's different methods. If I put D, and since I'm using Jupyter Notebook, I can actually click Tab, and these are a bunch of the different methods that are available to us for dictionaries. You can go ahead and check out the Advanced Dictionaries lecture if you want to learn about all of them. But in this case, we're going to look at some of the basic ones. So for instance, D underscore keys, close parentheses, since I'm not adding in any arguments there, will actually return a list of all the keys. And there's a similar method for the values in the dictionary. D.values will return all the values. And you notice here, they're out of order from what we originally printed out that dictionary. And that's important to note because remember, dictionaries are never going to hold a specific order. Since they're mappings, the way they keep track of things is through the keys and the value combinations. So there's no such thing as indexing a mapping. So we could index lists and strings since those are sequences, but we can't index a dictionary. What we'd have to do is call things by its key. So it's not a direct index of like D0, D1, etc. It's you're referencing things by their keys. Okay, so we have D.keys method to grab a list of all the keys, D.values to grab a list of all the values, and if you wanted a combination of those, we can say D.items. And that will return a list of something called tuples, or sometimes called tuples, of all the items. So if you notice here, we have a list, and we have this notation of these parentheses that are all the pair combos. So we'll learn about tuples or tuples in an upcoming lecture. And that's about it as far as just this beginner's introduction to dictionaries. So let's just go over everything we covered in this lecture really quickly. Remember, dictionaries are mappings in Python. They're different than sequences because they don't retain any order. So we refer to the values or the objects within that dictionary through their keys. In order to construct a dictionary, we use this curly bracket notation with the key name, a colon, and then the value name. And then we can call values by their keys using that bracket notation. Continuing along, dictionaries are super flexible in the data types they can hold. For instance, here I have a list inside of a dictionary. numbers, we can have dictionaries inside of dictionaries, and then you can call items from that dictionary, and then index or methods on those values as well. So we also learned about this quick notation of self-subtraction or addition. Remember, we could do that minus equals instead of doing something like this, which was that object self-reference minus. So that should save you some time if you're coding. And then to create a new dictionary, you can create new keys through assignment, just like we did here with that equal sign sort of assignment. And then here's the result. You can nest dictionaries, we went over that, and keep calling the keys to go further and further in those nests. And then we went over a few dictionary methods, the keys, the values, and then items. So hopefully by now you have just a good basic understanding of how to construct dictionaries. There's a lot more to go into here, but we'll be constantly revisiting dictionaries throughout the lectures. All right, great. So let's go ahead and move on to the next lecture.